in this video, I'm going to show you how do you differentiate implicity. So what is implicity? So implicity, your functions, this is where your functions where one is not isolated. What do I mean? Let's say for example you have y. Let's for example know that y is equal to 2x. You know that dy dx of this, you know that it is dy dx is equal to 4x. Now implicity, it is a situation whereby it's a function where you have a y is not isolated. For example, you have y squared plus x squared is equal to 4. Of course, here it will be very difficult to make y the subject to the formula. It will be very difficult to make the y the subject to the formula. Even if you can make, but it's something which is cumbersome. So we use implicity to differentiate functions where you have a situation whereby y it is not isolated as if the way it is here. As you can see here, y is not isolated. So in this case, as you can see, these functions, you have y is not isolated. Y it is within the function. So we are going to use implicity to differentiate these functions. So let's start with it. Number 1. So if you have been given this to differentiate, so I'm going to say this is y is equal to 16. So I'm differentiating y with respect, I'm differentiating this function with respect to x. So how do you differentiate this function with respect to x? So you know that dy dx of x squared, it is 2x. Now what about this one? This one, you know that dy dx, we are differentiating y with respect to x. So this is a what? This we call it a dependent, this is called the independent variable. This is what? Dependent variable. So what I'm going to do is to bring this one down, y. But look at this. Here, since I'm differentiating with respect to x, I'm going to add dy dx. Then this is a constant. It will give you what? 0. Now I'm looking for dy dx. So this one will cross the cosine to be 2y equals negative 2x. Look at this one. This one has crossed the cosine. It has come this side. It's going to give you negative what? 2x. I want to remain with it dy dx. Since it's the one which I'm looking for, I'm differentiating. I'm finding dy dx. I'm finding dy dx. So if you have a, then here you are going to remain with if this one cross, you have dy dx. Don't forget this one is attached. Then you have dy dx. Then this one will cross the cosine. It's going to give you negative what? 2x. Now what you're going to do is to divide both sides by what? By 2y. Then this one cancels. The final solution is going to give you dy dx is equal to this and this will cancel. Is going to give you negative x over y. So this is a dy dx of this function. Let's look at this one, the second example. So the second example, I'll do it here. So you have this. So how do you differentiate this one? So now this one, you have a product. Here you have one function, you have another function. So this one is a one function, this is another, we have another function. So I'm going to use what? Product rule. So let me start. You know product rule, for example, if you have y, two functions, you have v, y. To differentiate this, you know that product rule, y prime, it is u prime v plus you maintain the dy dx of v prime. So that's what I'm going to do. I'm going to differentiate this one. This will maintain. Then I also going to say plus. You differentiate this one. This one will maintain. Then you say plus. This will maintain. Differentiate this one. So here I'm going to do is this one. So you have x. Let's copy it. Then plus cos x is equal to 4. So what you are going to do now, Using product rule, we are going to say, using product rule, we are going to differentiate this one. This one, it is dual dx of x is 1. So we have 1. Then you maintain this one plus. Maintain x according to the product rule. Maintain x to be x. Differentiate this one. Dual dx of sine, it is a cos y. But remember that I'm differentiating with respect to x. I'm going to add the dy dx. Then you have plus. Then dy dx of cos, you know that it will give you negative sine x. Since this is x, we are differentiating with respect to x, so it's okay. Then this one is what? Constant. So now we are looking for this. So what I'm going to do, this will cross the cosine. You know that this is 1 times sine y, which is same as sine y. So this one will cross the cosine. This one, it will give you x cos y dy dx. Then this one, then this will cross the cosine. It's going to give you also this one. So those which doesn't have dy dx, they are going to cross the cosine. I'm just going to isolate those which has got dy dx on my left hand side. Then this one doesn't have dy dx, this one doesn't have dy dx, they will cross the cosine. This will become negative. So this one, let me cross this one to become positive. Then this will become what? Negative sine 1. Then you are looking for this. What I want to do, you divide both sides by what? Negative cos. Sorry, you divide both sides by x cos y, giving here x cos y. So this will cancel. We're going to have dy dx is equal to. So this one I've divided both sides by x cos y. Then I'm going to remain with it sine x minus sine y over. Then here I'm going to have x cos y. This is a dy dx of this function. Thank you very much. And in my next video, I'm going to differentiate a more implicit function, for example, for exponential, also for natural log. Thank you. Bye bye.